Yes, the name of the panel is The Role of Hydrogen-Based Power Generation for a Reliable Fossil-Free Energy System of the Future. And it's my pleasure to welcome my two experts here on stage. We have Dr. Reihaneh Zohourian. She is the Senior R&D Project Manager at EnBW, Energie Baden-Württemberg. And we also have Erik Zindel. He's the Vice President, Hydrogen and Decarbonization Strategy at Siemens Energy. Welcome. Yeah, at first, they have both given to me an introductory statement to show her position to the topic. And Reihaneh says hydrogen will be irreplaceable for German power supply to make up for intermittent renewable energy production such as wind and PV. And Erik says hydrogen re-electrification will be one of the major consumers of green hydrogen and is often overlooked in hydrogen roadmaps. So yeah, there are clear statements. And yeah, so at the beginning, my first question to both of you would be, why do we need hydrogen-based energy for the decarbonization? And what are the activities of your companies at the moment to this topic? And maybe we start with you.
Yes, and thank you very much. In general, we have to decarbonize our power systems. Power systems and as well district heating as well, that goes hand in hand. And the main way to do it is to increase the renewable energy. Build more wind, build more solar. The issue is that these energies are intermittent. Mm-hmm. And there are times of the year where there's not enough wind and PV in the system, and too long periods of time in order to be bridged with demand-side management or batteries or any other conventional storage technology. So we need as well flexible generation based obviously on a decarbonized fuel. That's very important. So that we can run what we call the residual load, which is exactly that difference between demand and production of renewable energy all over the year.
Yes.
In Europe, we're going to see probably long-term around 50 to 25% of the hours of the year where gas turbines running on hydrogen, which is the most attractive decarbonized fuel for this application, will operate. The rest of the year will have sufficient renewable energy, and the surpluses obviously will be able to be converted to hydrogen, which at the same time becomes an energy storage, large scale and also seasonal storage.
Mm-hmm. And what is Siemens Energy activity in this topic?
Yes, coming obviously from, especially in my background, which is very much gas turbines and combined cycle power plants, which usually run on natural gas. We have to now change all our portfolio to decarbonized fuels. And hydrogen is the most important one. And it's not so easy to do because hydrogen is a very nasty fuel with its extreme high reactivity, very high flame speeds. So we need to do quite a lot of changes to our turbines and to our power plants. And that's what we are currently doing. So developing hydrogen gas turbines to be able to run the residual load in a decarbonized manner in the future.
Mm-hmm. Super, thank you very much. I hand over to Reihaneh.
I do agree also with Erik. I cannot add much. So I think hydrogen is important for power generation in Germany. Photovoltaics and wind would not suffice. And I would say fuel switch projects of EnBW are great examples when it comes to hydrogen electrification. In South Germany, in Heilbronn, Alsbach, Stuttgart, Münster, we have power plants. We're going to switch them from coal to natural gas in the next step, and from natural gas to hydrogen until 2035. I guess even for Stuttgart, Münster, we have been ordering these gas turbines from Siemens. Mm-hmm. Exactly. And in total, we are investing about 1.6 billion euro for these power plants. They have been ordered and they're up to 20 volume% hydrogen ready. And we also considered in engineering and planning that we can retrofit them or adjust them easily to be run by 100% hydrogen latest at 2035. And in general, I would say we have also many activities when it comes to fuel cells as hydrogen technologies. as well as hydrogen engines. Especially also for heat. I would not exclude that. I would say hydrogen is also important when it comes to supply of electricity, but also heat, because many of our power plants are there. They're like CHP, our CCGT power plants, and they're also quite suitable to provide customers with heat as well.
If I may add to that one, the heat topic is really very important because those times of the year where there is residual low demand with lack of wind and PV is usually happening in winter, where there is a large demand for heating as well. So as we're going to more electrifying the whole heating supply for both buildings, but as well industrial processes, many of them with heat pumps, we're not going to have the electricity to run all those heat pumps at this periods of time. So if we have to build already the combined cycle power plants to cover the residual load, what better than to build them as cogeneration plants and deliver that residual heat at the same time, so that we have really power and heat supplied at the same time with a very high efficiency.
Yeah, super. Thank you very much. Already talking a little bit about the application of the power that we produce. I would also like to integrate our audience in a poll. So the question is, what do you consider the most promising application for hydrogen-based power generation? So we have some options to choose. And then we will hand back the question to you. So some people seem to take part. 100%? Okay, no. Okay, decentralized power generation for remote or off-grid areas, providing backup power and grid stabilization, and fueling transportation such as hydrogen fuel cell vehicles. We also talked about these topics today in other sessions. Yeah, so it's still moving. Okay. Yeah, so what do you think? I mean, I give back this question to you. What would you say is the most promising application from your point of view? Maybe we start with you. Difficult?
Just on the power generation side, yeah?
Yeah.
Definitely providing the backup power and grid stabilization is the most important one. That means it's always a complement to the renewables. Renewables are always cheaper in terms of levelized cost of electricity compared with hydrogen generation. So whenever you have wind and PV, you use that, but it's for those periods of the year where you don't have them when you need the hydrogen generation. Grid stabilization is extremely important because things like reactive power control, voltage control, short-circuit power, inertia in the grid are indispensable requirements to run a stable electricity grid, and all those what we call the grid auxiliary services came for free with the large conventional generators, with coal, with nuclear, with gas. As we're moving now to a more renewable business, there will be times of the year where there's no rotating generator connected to the grid, so we need to provide these services. And there are some good ideas about how to do that, especially with the new gas power plants that we have to build. So we can, for instance, run the generator always connected to the grid. We have a synchronizing clutch between the turbines and the generators so that you still can provide this auxiliary service. But we need them. It's very often overlooked. Decentralized power generation as well. Obviously, in Europe, we don't have too many decentralized power areas. This is more, for me, something like islands, island grids, which, by the way, are today often provided with electricity from heavy fuel, oil, and diesel, so extremely high CO2 emissions. Transportation, not so much, to be honest. At least for most of the applications, the direct electrification is a much more efficient and cheaper option. In some cases, we might see hydrogen or hydrogen derivatives, but if you can make it with batteries, you go with batteries. And grid-scale electricity generation, yes, but only obviously complementing the renewables, not as a complete separate alternative.
Do you see any other applications that are maybe not on our list? I don't know.
For
you
power
or
generation,
yeah.
yeah, the only thing that I would say is maybe what if you do not have a hydrogen connection? But we had a discussion before that, and especially EnBW has the issue of where to get the hydrogen from.
Yeah.
But I think that's one of the next topics that we'll have to discuss here on the stage.
Yes.
I can
Reihaneh, you want?
also comment on that. If we would like to use the power plants to make sure that we have stable power, then we have to also provide these flexibility instruments. Because in the first years, we are not going to have a hydrogen backbone or enough hydrogen in grids so that we can make sure pipelines or grids can also be used as storage. So probably we need to plan locally storage so that we are able to operate our power plants flexibly, which is almost probably not possible because we need gigantic amount of storage. And then if you think of caverns in North Germany, we have this problem that we have to, if we want to like operate the power plants flexibly, we have to also react quickly. And it's going to take a little time that we get the hydrogen. But with time, after a few years, then we have the hydrogen backbone and this meshed grid, as we have it today, for example, for natural gas, and it's not then complicated today, it's going to be much easier. But this is also a challenge, and I would say an open question that we have right now by EnBW. We have also been talking with our sister company, EnBW, who are basically, if you want to like fuel our power plants with hydrogen, we're going probably to use the hydrogen coming from SEL, so this Erdgasleitung, and this is being operated by EnBW. And this is also an open question for them, how or who is going to provide this flexibility? Is this the task of operator of grids, or the one who is going to run the power plants? So this is an interesting question to address as well.
Super, thank you very much. We will also later come to the challenges.
Yeah.
First of all, I want to also ask about the re-electrification methods. So there are, at the moment, these two methods. We have the gas turbines and we have the fuel cells. Which of this technology will prevail in the future?
You also have the engines, by the way. In general, these are competing technologies, so the best one will win for each application. But looking at especially fuel cell versus combined cycles, we see that combined cycles is an established technology. It's from a CapEx perspective significantly cheaper on a turnkey basis compared with fuel cells. It has at the same time much higher efficiency. With combined cycles, we're today at the 63-64% net. Which is something that the fuel cells are not yet there. We also have a much lower degradation. Then we have a lower sensitivity to the fuel, so we can combust also not 100% pure hydrogen. And on top of that, we have the fuel flexibility that we also need, because the plan is not to build hydrogen power plants from now on, because we don't have the hydrogen. That will take time. So the plan is, in order to get out of the coal, first to build many gas-fired power stations, 100% H2 ready, but which will operate on natural gas, and will then, as soon as hydrogen becomes available, switch to hydrogen. So you need this fuel flexibility between natural gas and hydrogen, maybe even a secondary backup fuel like methanol or whatever. So here the gas turbines are a very easy option. So at the end, it's not about building new equipment, it's also about, we have the gas-fired power plants, it's just retrofitting them to hydrogen. So for a large centralized grid, we expect very clearly combined cycles and gas turbine generation will play the major role. For smaller island grid applications, few megawatts, here fuel cells might be a very good option. And obviously for mobility applications as well.
Yeah, do you agree? Yes?
I have a similar opinion. I just want to add something to that about hydrogen engines compared to fuel cells. I think there it depends on the application. If you're looking more for heat, then probably it's more appropriate to use hydrogen engines. And fuel cells are interesting when we are, for example, we need more electricity. But we have to also be realistic. We don't have many or large hydrogen fuel cells, not natural gas, but hydrogen fuel cells right now in market, and they're quite expensive.
Yeah. Thank you very much. So, yeah, we already talked a little bit about the challenges. So, looking at the technical requirements that have to be met for re-electrification, where do you see the biggest challenge here? Maybe this time we start with you.
Yep.
I think that one I mentioned is this flexibility
Yes.
that we need for the power plants. We have to see how we can manage it. Either we have to plan local storage. It's almost, I would say, probably impossible. Or we have to see, for example, we have to see if it's maybe even more economical not to run the power plants flexible, but that's going to be also difficult because that's not what we are expecting from hydrogen. We expect that they're gonna like make up for this intermittent power. That would be one of the challenges that we have. Or for example, when it comes to turbines and so on, I don't know how much it is possible to design turbines so that we are flexible to use hydrogen, ammonia, or it's, I guess you can say something on that, but probably it's not possible.
How about the ammonia discussion?
Yeah, well, with ammonia, ammonia has the big advantage that you can store it and transport it in a liquid form, which in some applications where you do not get access to a hydrogen network might be a different option to get a renewable fuel. We as Siemens Energy were also looking at ammonia as a fuel for gas turbines, but for several reasons our technology is going the cracked ammonia route. That means we first crack the molecule of ammonia into hydrogen and nitrogen, and that is what we burn in the gas turbine. So we're not combusting direct ammonia in the gas turbine because of toxicity issues and NOx emission issues. But in general, the idea is to have very fuel flexible turbines. A 100% hydrogen turbine will always be able to run on 100% natural gas, and very likely as well 100% cracked ammonia. And we're also looking at the possibility to add secondary fuels like methanol, which is also something that you need to do occasionally because we all have learned from the Ukraine war, you need to be ready in case the main fuel fails for whatever reason. So that's on the fuel flexibility. Flexibility of operation is also extremely important because these power plants will have to cycle quite a lot. It's always up and down. You may have heard of the duck curve. So we expect 2 or 3 starts a day and quick ramp ups and ramp downs in power. So the power plants need to be able to do that. And for us, that means develop all these technologies. We're already capable of offering 75%. So the 2 gas turbines that we have, that we're now installing at Stuttgart Münster for EnBW are already 75% capable of burning hydrogen. They're 100% hydrogen ready. That means we're going to retrofit it to 100% capability as soon as you have the hydrogen available. And from a technology perspective, OEM, I think we are not the bottleneck. The bottleneck is very clearly availability of the fuel at the power plant boundary. Yeah. That means we need the pipeline. We need the underground storage in large scale from day one because of the significant seasonality in production and use of hydrogen. We need the electrolysis, we need the renewable energy upstream, and it's not just the infrastructure, also the molecule itself we need, and we need it in extremely high amounts. Yeah. Just for you to give you an idea how much a large gas turbine burns in terms of hydrogen, a large utility turbine, 600 megawatts, If you would feed that with hydrogen trucks, you would need a truck every 30 or 40 seconds. So we need a pipeline connection. There is no other way. Only for the very small turbines, we can think about the local storage, but then we're running into the issue, how many hours of operation do we have? And quite often we need a little bit more the seasonal storage type as well.
Yeah, thank you very much. There is a question from the audience, maybe a little bit provocative. Nuclear energy is less energy and resources intense and much more efficient, meanwhile safer than in the past. So why the huge trouble with hydrogen?
Yeah, nuclear energy, if you have an existing reactor, that's usually a cash cow. That's very open. When we talk about what's the future model split, fuel split between the different generator types, is nuclear an alternative to renewables and hydrogen generation? That is more a regional question. It depends on the local conditions. In areas like in Europe, where we have rather good access to renewables, we have a very, very cheap energy coming from the renewable energy, which complemented with the hydrogen makes probably a cheaper production, cheaper electricity cost compared with nuclear. On the other hand, nuclear, the costs have increased significantly in the last projects. You need 30 years amortization periods, 60-year lifetime of these plants. The investor risk is extremely high for this power plants. So for the normal international project finance, probably not really bearable at all. But there are some areas in the world where there is a lack of renewable energy. Think about Japan, South Korea, Indonesia. Here, nuclear energy might play an important role in the future as well. In Europe, I would expect on a long term, the mixture of cheap PV, wind, and hydrogen re-electrification is probably what we're going to see.
Exactly.
You agree, right?
Yeah.
EnBW has a long history with nuclear power production, right?
Exactly,
Yeah.
exactly.
Yeah, coming to maybe another question which is connected to that. What do you think about the current discussion on the market design of, Yeah,
I have to, I'm actively involved in some of the discussion of the market design, because the issue at the moment in the power plant business is that there is no business case for investors to build new power plants. We need to build them. We want to get out of coal, and in order to get out of coal in Germany by 2030, we need to build 20 to 25 gigawatts of new gas capacity. But there is no market design at the moment that makes it attractive for investors to invest into new generation. The government has realized that, and they're now working on a new market design. It will probably end up with some sort of capacity payments, because the big issue is these power plants, these gas power plants, are always the last ones to get in. So they're always dispatched last, and by the very nature of the merit order system, they are getting remunerated just with their marginal production costs.
Yeah.
But there is no way to amortize the investment. So without a functional market design, nothing will happen in this country. We're saying that very clearly. There is occasionally some cogeneration plants that still have a business case because of the cogeneration laws, but the 20 to 25 gigawatts we're not seeing yet with the market design that we have today.
Yeah. Do you agree?
Yeah, I do agree. I can also comment on that. And I think the market design is also mainly a political decision. So the market should be organized, I would say. So we need these CCFDs, or in long term, it's important that the hydrogen price can also compete with natural gas, so that we make sure that we can use hydrogen to provide electricity. And this should be also politically organized. Yeah.
Okay, yes, yeah, I agree, absolutely. Yeah, looking a little bit at the time, we have another question. It goes to Siemens. Yeah, you see the question there.
Siemens Energy.
Siemens Energy, yeah, you're not the same, it's another company, I know. What is your definition of H2-ready power plant? Does this plant have to be capable of combusting 100% hydrogen now?
Hydrogen readiness always means the plant is prepared for a later retrofit to hydrogen. So it does not really say it can already burn hydrogen, it's just it is being prepared. We have set the right materials, we have put explosion protection in the right areas, we have additional space in the power plant for additional systems that we have to retrofit later. So it just means it's prepared for a later retrofit. We tend to differentiate very clearly between hydrogen readiness and hydrogen capability. Unfortunately, in the public discussion, even our company, people mix it up all the time. But the goal is now to build the new power plants always 100% hydrogen ready. But the actual reconversion, retrofit to hydrogen will be done as soon as hydrogen becomes available at the power plant.
Okay, thank you. And then Andreas wants to know, in heavy-duty transportation, batteries seem to be no option. Do you think this will change in the future? Any promising developments ongoing? Any one of you wants?
In my personal opinion, I think also for heavy-duty, exactly transportation, we are going to probably use synthetic fuels as well as hydrogen. So if you take a look at also plants that automobile industry, for example, in Germany they have, I would say maybe liquid hydrogen even, or hydrogen or synthetic fuels probably is going to be the best solution. But when it comes to like normal cars, I would say electrification is the best.
Yeah. Well, we're not, I think, the experts on the transportation business, but what I have heard, and obviously we're looking as well into the other sectors, even for heavy haul truck transportation, there are more and more companies that are betting on batteries. Obviously, it's a couple of tons of batteries, but the point is not, you do not need to run 2,000 kilometers on a battery load. You just need to run 400 kilometers and then be able to recharge in 30 minutes, because that's what the driver has to stop and do a pause in any case. And remember that hydrogen is a very expensive fuel. You have the losses at the hydrogen production, you have losses at hydrogen compression, and then you have the fuel cell, which runs at 40 to 50%. So effectively, from the renewable energy, we're just using 25% of the energy, while with batteries, we're close to 85.
Yeah.
That is a huge difference in cost per kilometer for the energy that you supply to the truck.
Yeah, for sure, yeah. So I would say the last question, and then we look in the future a little bit. There's a question saying, why would you fire a gas turbine with 20% hydrogen when the reduction of CO2 would be then insignificant?
I think the point is, I think there are two questions here in this question. The first one is the hydrogen blending ratio. Usually we as technology providers, we tend to talk in volume percentage, which obviously from an energy perspective is much lower. 20% is around 6-7% CO2 emission reduction only. The question is, how will hydrogen re-electrification happen? Obviously there is no business case behind. It's always a more expensive fuel than natural gas, so the operators will only do that once they are being forced to because of maximum CO2 emission limits. And then if there is a CO2 emission limit that you can solve with 20% co-firing, that's what you're going to do. Obviously, the goal is at the end to go to 100%, and we're seeing, by the way, a very big push to get as quickly into the 100%. So not too much blending ratio in between. The big issue is how to get the hydrogen to the power plant.
So we have a specific position on that by EnBW. We think that we are going to use 100% or natural gas, so probably we're not going to mix hydrogen with natural gas, because it's quite difficult. We had also projects on that, like Hydrogen Insel, Hydrogen Island. It's about mixing hydrogen with natural gas in grids. It's quite difficult. I mean, it works, but when it comes to large-scale application and the quality of gas in grids and the customers that are quite sensitive to the quality, then we think that it's going to be very difficult. So we expect that we are going to have 100% hydrogen in pipelines, and then we are going to run our power plants with 100%. And I guess 20% comes from, because I was expecting some at the beginning that our power plants are 20% hydrogen ready. In total, not the turbines, but if we also consider BOP and so on. But exactly, we have been planning this in our pyramid, like engineering space requirements and so on, so that we can retrofit our power plants in just a few months to be able to use hydrogen, 100% hydrogen, to provide electricity and heat. So this has been planned and is going to be also permitted.
It was already a look in the future. Yeah, maybe you want also to contribute, like last sentence, what do you expect? When will this technology be ready to market? What about
it's always
the
as with new technologies, people tend to overestimate the potential on a short term, but underestimate it on a long term. So my expectation is it will take still some time to get everything running, but then adaptation will be probably quite quick. I think the pressure for decarbonization is very large.
Yes.
And from a government perspective, enforceability, we have seen the discussion with the heat pumps in the public in the last couple of weeks. It is much easier to enforce large decarbonization targets on 50 large generation companies than on 50 million voters. It may not be the most efficient economic way of hydrogen use in the next years, but it's probably what's going to happen.
Yes. Super, thank you. That was a very good last sentence. And big applause to our two experts from the last panel discussion.